So then, if we're given x is equal to 1, it means that we will find the value along this line, going through 1, right? And then, if x is equal to 1, what is the value of y? Very good. 1 as well. 1, 2, 3 here. Then in the y coordinate, let me draw a dot line. Okay. To simplify it, just imagine there's a line right here, horizontal line. It means that the intersection of these x and y value, it is right here. This point belongs to the, just imagine there's a line here, right? This point, the red point here, belongs to the graph of the function f of x, okay? At x is equal to 0, what is y? Very good. It means that at this position, x is 0, y is 0. And at x is equal to 2, y will be 4 here, right? So 2 in this coordinate will be this point. Okay, so we connect all these points. This is half of the graph of the function f of x. And the negative value, we do the same things, right? And we know that they are symmetry. So let's go through these. Okay, this is the graph. So how about if we're given the graph and given a value of x, can we find the y value of a given function, right? And there's a very useful test here. We call it the vertical test. It is in section 3.1, the function in the previous class, 1021. You can review it. So a function, when we give an input, one value of x, given one value of output. So the test will be like this. If we draw at a certain position of x here, then we draw a vertical line. And suppose we're given the graph f of x is this curve here. Okay? Then the intersection of the vertical line and the curve is this point, right? So we see that if the vertical line here cut the curve only at one position, it satisfies the definition of a function. So on the left, you move the vertical line here from left to right. It's always cut the curve at one point. So this satisfies the definition of a function, right? However, at this curve, if we draw a vertical line right here, it cut the curve at 3 points. Sorry. So, is it a function? No. This is called the vertical test, okay? To check if it is a function or not. Then, if it is a function from this intersection, we project to the y-axis. It means that we draw a horizontal line that cut the y-axis at this point, and this point is the value in the y direction, the value of the function. So just reverse it. Okay? If you don't remember it, just that's it about the function and curve. So now the limit. We want to understand, okay, if x in the domain here, if x comes closer to a value a, we wonder what fx approach to. And we call it limit. Okay? For example, yesterday, here, the infinite limit. Here on this graph, for example, the vertical test, which is, for example, the vertical test, let's say this line, is always cut the graph, the blue graph here at one point. It is a function, right? For example, if the value we just made it up, the value in the x direction here is 1, right? What is the value in the y direction of this curve? We first find the intersection here, right? And then draw a horizontal line from that point here. Horizontal line is perpendicular here. And this point is the y value of the function. So it is f of 1. It is right here. It's not given a specific value, but it's how we find it, okay? And we wonder if now, instead of saying it 1, we can play it with a general notation, x0, for example. Then here should be f of x0. Do you agree? Then we wonder if this x0 here, it moves, approach A, how this guy behave, where it goes, right? And according to the graph, it will go from here to here as x0 approaches A, right? This is a limit of the function. And we see that if we continue come closer and closer to A here, it will go bigger and bigger, go to infinity, and we call it the infinite limit of this function when x goes to the left side of A. Because it goes from the left side of A, therefore we say that the limit of f of x when x go to the left side, what is it? It should it be minus or plus? Minus, right? Go from the left is positive infinity. The same thing. How about if x0 approach A from the right side? What is the limit of this? The same thing. It will be somewhere here, right? If it is here, then it goes this way and also go to infinity. Both left and right limit go to infinity. So we can say that the left-hand limit and right-hand limit are the same, are both go to infinity. So we can simply write lim of fx as x approaches A is infinity. The same things, it will go to negative infinity. Is the concept of limit clear now? Okay. We just want how it behaves when x goes to a certain number. Okay. How fx behaves. Very good. For people on Zoom, are you okay? Do you have any question? Okay, good. Thank you. Now, sometimes the same thing. When x approaches the left side of A, it is positive infinity, and it goes from the right side, it is positive infinity. This is other kinds of infinite limits, okay? Or goes from x approaches the left side of A, goes to negative infinity, or x approaches the right side of A, it goes to negative infinity. And here, remember, this is where fx approaches to. So don't be confused between these two, okay? Okay, and remember, if we say that x approaches A from the right, A plus, it means that x is strictly positive, larger than A. Okay. Same thing. If approach the left, it means x is strictly smaller than a. Okay, that's all about limit. Here are some other examples. And sometimes we want to understand if x becomes very large, right? A could be go to infinity. It means x go to very far on the right, or A could be very far on the left. Anyway, these are some other examples of infinite limits. Wow, it takes a lot of time, right? But I just want to make sure that this concept is clear now. Then we can move on. Okay? Good. This is the sample test I pushed on Moodle. You can check it. And this is the first question on it. Now help me with this. If we're given the graph of the function like this, the black one here, and then look at this. There's a hole right here and the dot right here. And it continue like this. There's a hole here, a dot here. Continue going up, and here imagine this is infinity here. And then infinity here. Answer this question. What is the limit of f of x when x approaches -1? Good. Here, -1 is right here, right? Then we see that both branches of the graph approach this value, and from this scale, we know that this position is 1. Therefore, answer here should be very good. What is the value of this function at 1? Good. Remember, it's tricky here. Imagine we're drawing a graph of this function. It draws up to here, and then we have to move our hand and make a solid dot here. And this is in the y direction, it is 2, therefore f at 1. Oh, at 1, then it should be here. But this is a type of what I want is it's also 1, but what I want here should be f of -1. This is what I meant. Okay, it's 2, right? Just want to show you something. The same things. How about limit of f of x is x approaches 2 from the left? 4, good. How about x approaches 2 from the right? Good job. How about the limit when x approaches 2 in general? Tricky. What do you say? Good. Does not exist. Why? Good. Because the left hand limit and the right hand limits are different things. So the limit does not exist at this point. Good job. Okay. What is f at 2? According to this, it is 1. Very good. So what is the limit of fx when x approaches 3? Yes, they all go to infinity, right? Good job. How about when x goes to infinity? Yeah, the graph becomes very small. According to this trend, we see that the graph will come closer and closer to 0 here, right? How about x goes to -infinity? Very good. So you earn 20 points easily. The test one. Okay. Very good. Is there any other question? Good. Good job. I think I'll skip this one for now. I'll try to revisit it when we have time, okay? But for now, it requires some knowledge about sine and cosine. I will show you later. But for now, yesterday, and the day before, we computed some given equation, right? Some function, and we guessed the limit. Today we will, hang on.